Okay, my dear, today we descend into the abyss of code and the piscine with our first serious exercise, which is ftprints comb. So we have to create a function that displays all different combination of three different digits in ascending order, listed by ascending order. And this is the output I want in my terminal. 012, 013, 014, 015. You got the point, right? You need to list all the numbers in ascending order. And they have themselves to be in ascending order. This is going to be the prototype. So a function that doesn't take any input, avoid here, and doesn't take back any output. Okay, let's jump into the code. In the first line, I include my file Unix standard, so I can use my write function. And then I declare and implement a routine, a function, which I've called write n, that stands for write number. We will examine later this function because it is specific to my code. So for now, it doesn't make a lot of sense. In my main function, I call the print combination, which is the function required by this exercise. And this is the function print combination in all its glory. As imposed by the prototype, I have a void here that stands for no return value and a void as an argument input. Now, I will line by line explain what I'm doing and hopefully you will understand this algorithm. This is not very complex, but as well not very simple compared to the previous exercise. So, my dear, you need to strive on a daily basis. You need really to challenge your mind, and this is like a starting point for you. I mean, this is complex if you're just starting out coding like myself. That initially for me, this exercise was like, I will never do it by myself, but eventually I did. And you will too. In the first line, I declare an array that I've called V. V stands for vector. In C, arrays are also called vector. So the words array and vector are interchangeable. They have the same meaning. So I say, dear compiler, create a vector that has 5 elements, and these elements have to be a char. So the compiler is going to allocate in memory 5 bytes and is going to call this data structure V. To understand this line, of course, you have to understand arrays and how they work. This is a really basic concept in programming and in C, of course. As usual, I leave you a link in the description. So just go in the description, check some tutorials about arrays, and then maybe come back. In the following 3 lines, what do? I initialize with some values. I just say, okay, in the first position of my array, because we start from position 0 in computer science, put the character 0. Go in position 0, which is the first byte of my array, and set the electrical state of that byte to which number? Do you remember from ASCII code? To number 48. You see? The symbol 0, the character 0, this is just a convention, the way it is. The ASCII code has been made in this fashion. So 0, the character 0, is 48. Let me repeat myself. Here I say in position 0, so in the first lot, set the electrical state of that byte to 48. This will represent the character 0. That later I will flash out in my standard output, which is my terminal. Okay? This is pretty simple stuff. I do the same with this byte in position 3, and I set the electrical state of this byte to comma. Again, comma is number 44 in my ASCII code. So what do? I do the same. I just turn on and off the transistors, my light bulbs, in position 3 of my array. For position 4, I do the same. I put a blank space, which is the ASCII code. Let me check the number. I remember 32. Okay, so it is the number 32. In human words, dear compiler, allocate 5 bytes in memory, call this structure, data structure V. V stands for vector, which is a fancy way to call an array in C. Inside position 0, position 3, and position 4, put these electrical states. Okay? Thank you very much, compiler. This is the way I'm having a dialogue with my computer. I'm trying you to give a glimpse on how I think about code. This is the way I visualize what is going on, what is happening. I hope you find this approach, this mental model of seeing code useful. now I want to show you something interesting. We have to deal constantly with these ASCII code. From 48 to 57, we have all the numbers. Then we have all the chars, uppercase chars from 65 to 90. And then we have from 97 to 122, all the lowercase chars. The rest is padded with some random symbols that have some meaning in our language. And from 0 to 32, we have all the symbols that are not representable. Like, for example, space. You don't see anything, right? When you have space. Then you have, for example, the new line character, which is number 10. We have the null character, which is a sentinel value that we use for ending string, but for now it's not important. And all different values that for now are not important for you. Just visualize this map and create your mental model for this. Now look carefully to this slide that I've created. I declare a char that has value 1. Remember, the value 0 in the ASCII code has value 48. The char 1 has value 49. Do you see the electrical state of my byte? You have the bytes that have value 32, 16, and 1. 32 plus 16 plus 1 is equal 49. Indeed, this is the electrical state that represents the char 1. Beneath, we have another electrical state that this time means 2. And at the last position, we have the electrical state for 3. I'm sure you already understood what I'm trying to convey to you. You see that we have a sort of prefix and we have the value itself. What do I mean is that for all the numbers in the ASCII code, we have the same prefix, which is 0011, and then we have the number itself. We have the 1 for the char 1, the number 2 for the char 2, and so forth. So this responds to the question, why the heck the char 0 is the number 48? Well, you have your response here. In this way, it is pretty straightforward to recognize the char 1 even in its bit form. Do you agree? You know that for representing all the possible numbers, symbols, which are 10 from 0 to 9, 4 bits are totally enough because we have 16 possible patterns. Indeed, 4 bits conveys 16 possible outcomes. This is basic combinatorics in mathematics. So I keep my 4 less significant bits for the number itself. And the most significant 4 bits, I leave for the prefix. So I have 0011 and the number. Okay, this is like where you're calling someone. You have a prefix and then a number itself. This kind of bits are called flag bits in computer science. This is a pervasive concept. With this slide, I just wanted you to understand why exactly this is the way it is. The ASCII code is well thought of. It's not just a random piece of paper. This, of course, holds also for charts. So we have the uppercase A, which has this electrical state. We have a prefix, this time of 3 bits, because we have 26 chars, so we need 5 bits to represent. 5 bits have 32 patterns, so they are enough to represent all the 26 chars. So I have my prefix, which is 010 for my uppercase chars. And then I have the number of the char itself. So for the uppercase A, I have the number 1, the number 2 for B, and so forth. The same holds for lower cases. So we have char lowercase a, number 97 in binary, which is this time a prefix of 011. Okay, do you see the pattern? Wonderful. This is just something that I wanted you to see because I think it's pretty interesting. Now, we have 5 bits that can represent 32 elements, 32 symbols. So we have 26 chars. To reach 32, I still need 6 symbols. Look carefully now. I have from 65 to 90 all my uppercases. So here at this char, I am at 26. To reach 32 and complete all my possible patterns and then go into the lower cases, what has been done? We have a padding here, you see? You have 1, 2, 3, 4, 5, and 6 symbols that are gonna pad to reach the value 97 and to maintain consistency across uppercases and lower cases. Okay, you see it? Basically, that's it. This is, I think, interesting and maybe important for you to understand. Everything in computer science is well thought of by people very, very smart. So nothing is random, allegedly. Okay, now back to the code itself. As you can see here, I created something really monstrous, which is a 3-nested while loop. What the heck am I doing? I'm sure you are already very knowledgeable about the while loop and how it works. It's very simple. performs some operations until a certain condition is met. Now, what I want to create here, let's dive into this block. So my most external while loop has this exit condition, which states the vector in position 0, so the first element, has to be less or equal to the char 7, which is 48 plus 7. This is a number. This is a number, right? It's 48 plus 7. Because the reason we were talking before, 7, the char 7 is 55 for the operations of the computer. Until this holds, here I said that the first element is equal to 0, aka 48. This initially is true, right? What do? I set this time the value in position 1 to the value of position 0 plus 1. You remember, I need a structure that has an ascending order. So I just say, hey, the value in position 1 is equal to 1, this time at the first loop. Then I enter another block, which is this one. This block has another condition, which is until the value in position 1 is less than the char 8. What do? I just set the value in position 2 to the value in position 1 plus 1. You see this? You understood the path here? I just initialized my vector to 0, 1, and 2, exactly like the exercise wants. Then I have my final block, my final while loop, which holds truth until the value in position 2 is less than 9, okay? The char 9. What do I do then? Well, I write my number. I have my subroutine that I will show you later and I will explain. And then I just increase the value in position 2. Okay, let's try to deconstruct the structure. I have an array that I've initialized with value 0, 1, and 2. At the position 3, position 4, I have a comma and a space. They don't participate in my computation of numbers. They are just there for outputting format reasons, as you will understand. Now I have these three numbers, which are 0, 1, and 2. And I have to increase these numbers, maintaining the ascending order. So let's start from the very basics. How a number of 3 digits work? I mean, what is the algorithm that allows the number to grow? Just think about a car odometer with 3 slots. If I want to increase the number, I just start from the least significant value and then increase it. So starting from the number 000, I just go in the least significant slot and I increase the number. And just rotating the odometer, right? I just go 1, 2, 3, 4, 5, 6, 7, until I reach 9. At that point, what do? I have to zero my least significant bit and then increase the bit which is in the upper position, right? And then again, I have to do my loop, increasing my number in the least significant bit, and then the same. You see this pattern. You have a while loop, which is at the least significant bit. You have while this number is less than 9. I have another loop, which is in the position upper less significant bit, which is the same, while this number is less than 9, and so forth. So I have a series of loops, which is embedded in the number base 10 itself. Do you get my point? Here, what I'm trying to do is to recreate this intrinsic property of numbers, of increasing themselves, okay? I say, you see this while loop, the most internal, the most nested one, it is for the least significant bit, which is the one in my position 2. And I say, until this is less or equal than 9. So this while controls my least significant bit in my artificial number, okay? This control the bit in the position superior, so the bit in position 1, and this control the most significant bit, okay? This can arrive to 7, and this arrive to 8. So what is my last digit? Well, it is 7, 8, 9. This is the biggest value I can represent, maintaining the ascending property. So let's really do what the computer is doing. I enter this block till the char in position 0 is less or equal than 7. And then I do all my stuff. I initialize the value in position 1 and the value in position 2 inside the loop itself because I want to embed, pay attention now, I want to embed here the ascending property with this +1. So every time I write my number with my subroutine that I will show you. What do? I increase the value in position 2 until this value reach 9, like a normal number. Okay, I have the number 9, then this while is broken. And then what do? I increase the value in position 1. So the value in the upper position, like I told you before, like a number. I arrive to 9, okay, I have a 9, and I increase the other one, like a simple number, like a simple odometer, okay, pretty simple. Then I go upstairs, because now I find myself in this block, and I say, okay, is this value less or equal to 8, which is the maximum value? Yes, it is. Then I refresh the value in position 2, which was 9, right? I left it 9. I refresh it to which value? To the value which is in position 1 plus 1, okay? So when I go into my while loop, I have the new value refreshed exactly one value more, so in ascending order. What's the point of that plus 1? Well, the point of that plus 1 is that I can skip this code, which is every time to check if f in position 1 is major to v in position 0, and v in position 2 is major v in position 1. That plus 1 is gonna forcefully create an ascending array all the time. I have it here and I have it here, okay? So this 3 while nested loop is gonna mimic the property of a number itself. It's gonna turn the numbers exactly like a number, a normal integer. Think about an odometer. This is a good mental model, mental visualization for this algorithm. If I have 5 while nested loop, what do I mimic? Well, a 5-digit number, and so on. Of course, this doesn't make any sense if I have to make big numbers, but for our exercise, it's perfect. I just need 3 while loops, and all the time I refresh the value exactly like I want. Now let's check my write function that I've created. So this is pretty simple. This function doesn't return me anything and takes as an input an array. Here you have really to understand how array works, because this is not an array anymore. This is a pointer. So just watch tutorials. I will leave you links in the description that explain very well this concept of arrays and pointers. It is not that difficult, even though people think that pointers and arrays are tricky. So I have my array. I say, if what? If v in position 0 is equal to 7, the char 7, and v in position 1 is equal to the char 8, and v in position 2 is equal to the char 9. I recall to you ad nauseum that these are just numbers and they are encoded in my fantastic ASCII code. So we have 55, 56, and 57. Perfect. What do? You just write my array. I don't have to write it with an ampersand before it, because you have to understand arrays, okay? Just watch the videos. And I say, okay, write in my standard output, which is the value 1, 3 bytes coming from the array. Only 3. I don't want to write the colon and the space, because this is the last digit. This is the last configuration of my RAM that I want to flush out in my standard output. So I say, write only the first 3 bytes. Why 3? Because, well, a char is only 1 byte. And then I say, after that, just write 2 bytes coming from this string constant, which is a pointer. Again, maybe tricky for now, but fundamental of fundamentals, pointers. Write a point and a new line character. So to end my program, essentially. Otherwise, what do? Well, otherwise you just write my array. All my array, which contains 5 bytes, as you can see from here, okay? So this is all the program, and as usual, let's compile our code and then let's run it. As you can see, I have my series of numbers in ascending order. My last value has been written with a point here and with a new line character here. Indeed, I have this line which is written on the new line. So my write routine was looking for this specific pattern, otherwise it was just flashing out these 5 bytes, which are 6, 8, 9, in this case, a comma and a space. Every single of these 5 bytes element has been processed by the write function. So a reasonable question would be, why did you use chars data type instead of integers immediately, like putting a 0 here a real zero, an integer zero. So just writing like this, a zero, and then maybe, and then in my conditional, just using the real number itself, like this. So just changing here, and then here putting, I don't know, int. Why? Well, because my write function to work requires chars. As simple as that. So I decided that, well, I'm gonna use directly chars. This is not gonna be a big deal. Why? Well, because chars are just numbers, as I repeated already 100 times. They are just numbers. If I say 9 as an integer type, so I have my bits configuration exactly like an I, or if I say 57, what is the difference? Well, there is no difference as long as I do comparison between chars. Here I have, for example, while v in position 0 is less than 7 char, v in position 0 is 0 char. So it is like the number itself plus 48. This is like the number itself plus 48. So they cancel one each other. I can work with chars exactly like numbers. I just have to recall that at the end of the day, these are chars and not integers. But I can, the comparison here from while char 0 is less than char 7, it's the same as telling while the number integer 0 is less than the number integer 7. It's the same thing, right? You agree with me? I just save time here with the write. I have immediately my chars ready to be flushed. That's basically it. Okay, this is the first serious exercise that you have done. I have here another algorithm which is different this time, but that gives back the same output. As you can see, I have my function here that I've called PC, that stands for print combo. And then I've made another assumption here. I've created an array with the initial ROM electrical state, you can see it like that, and with the final electrical state. Then I create something else, blah, 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 blah. I won't explain this code. It is already enough that you understand the previous one. I want just to show you that there are different ways of solving the same problem. Before everything, let's just check if my code works. Okay, compile and then launch. As you can see, it works. I just have to format this one, but doesn't really matter. It's not important. Okay, if you want, just screenshot this and try to understand what is going on. The key lesson, take-home message is just there are different algorithms for the same problem. This is why we study algorithms. We search for the easiest, fastest solution at the same exact problem. Okay, for this problem it's basically it. It's already a lot of meat to digest. Okay, thank you for watching. See you on the next one.